All right, looks like I'm up on the screen share. Hey folks, I am Matt Gowie. I'll be presenting instead of Austin tonight. Let me know if you can't hear me. I'll be watching the chat. Looks like I'm up on the screen share. Hey folks, looks like I had some audio problems already. But yeah, I'll be up on the chat. Tonight we're going to be talking about AWS Elastic Container Service. I'm going to try and give you folks an intro to this important service within AWS, something that's like kind of growing year over year. And I'm lying to you a little bit with this slide already, so I apologize. But we have Docker plus AWS equals Amazon ECS here. There are other ways to ship Docker containers. We'll talk about them shortly. ECS is just one of them, though. I want to point that out. It's probably AWS's preferred method that you ship containers using ECS. But yeah, want to just show this. All right, so let's get started. Okay, so again, my name is Matt Gowie. I am your presenter for tonight. I am the owner of Masterpoint Consulting. I focus on AWS, DevOps, and just general cloud work. I do a lot of work with Terraform and yeah, with AWS. I'm certified in both AWS as a solution architect and with HashiCorp as their Terraform Associate certification. And I use ECS for multiple projects, both open source and client projects. So it's something I work with a lot in my daily day-to-day, and yeah, I know the ins and outs of it. Hopefully I'll be able to answer your questions. So feel free to, again, shoot them into the chat that we've got going on. And I see a couple of you already. Hey folks. Nathan, good to see you. Yeah. So let's jump into what we're going to be talking about today. First, I'll be jumping into core concepts, things like what is Docker, what is a couple of AWS services, and then we'll jump into the meat of it with what ECS is, what it's doing for you, kind of what is this beast, what is this massive service that AWS is offering for us. And we're going to talk about prerequisites, like what you need from your AWS account to actually get started with ECS. We'll talk about the terminology and like domain object model that comes along with using ECS. And then we'll break down a task definition. Task definitions are an important building block within AWS, the ECS ecosystem. So I want to make sure that you walk away with understanding what that is and kind of how it works. We'll talk about launch types. We'll talk about placement strategy and constraints and auto scaling. Bunch of fun, smaller topics within ECS that are all important to understand. And then we'll go into a demo. I will show you an application that I have running in ECS. I'll kind of walk through a couple different things that we've talked about throughout the deck. And then we'll move forward from there into just some tips, some tools that you should use, and then we'll go on to resources and questions. And quick note, I have Jake here. My girlfriend and I have been watching a lot of Adventure Time. If anybody's a fan of Adventure Time, you'll like some of these slides. I kind of peppered it throughout. I just introduced her to it, so it kind of was on my mind. So just in case you're interested why that showed up, that's the reason. All right, some core concepts. What is Docker? Right? I think that if you don't know these things, that's totally okay. I hope that this talk is useful to you. Most of you might know these things if you're in software engineering and working in AWS. You're going to know some of these topics, but I want to go through them a little bit anyway. Docker is a tool set designed to make it easier to create, deploy, and run applications using containers. I'll get to what a container is in a second, but basically, Docker is the tool set that popularized containerized applications, and it really revolutionized the way we run software and how it's shipped. A lot of companies have moved towards Docker, and it really doesn't seem to be slowing down. So it's an important tool to know. If you don't know it, I suggest getting into it as in your software development lifecycle and including it there. But what is a container? What does it mean that Docker is the thing that popularized containers? Containers are packaged up applications that allow you to run them anywhere, right? You have your source code, your libraries, your dependencies, all together in this packaged thing that allows you to run your application on a Windows machine, on a server in the cloud, on your local machine. So it makes it really easy to make your application movable across different environments, to make sure that what you're running in the cloud, what you're running on AWS, is the same of what you're running on your local machine. So yeah, that's what a container is, and it's huge. It's can be used many times, and it's an important concept to understand for this talk. One thing I do want to mention is what Docker does is it allows you to build an image, and an image is actually the package, and then you take that package, that image, and you run that as an actual container. A container is the running instance of an image, just to kind of clarify that. That kind of covers the real basics of what Docker is and what a container is. We'll go on to a couple of AWS concepts I want to make sure everybody knows about. What is an EC2 instance? EC2 stands for Elastic Compute Cloud. It is AWS's base building block. All of AWS is, you can think about as being built primarily on EC2. And it's basically what an EC2 instance is a virtual server for you that AWS provides and that you can SSH into, that you can run your application on, and you can do whatever you'd like. So it's one of the core components of how AWS kind of thinks of the world, and we'll talk about those a bit throughout the talk. And then what is an auto-scaling group? You know, I think that it's important to understand that because we're going to talk about auto-scaling in regards to containers, and that maps to auto-scaling within EC2. So an auto-scaling group is responsible for scaling your EC2 instances. So if you have 1,000 requests coming in, you can scale out, or you have 1,000 requests coming in and you have one EC2 instance handling those 1,000 requests fine, then that's all thumbs up. But let's say that 1,000 requests turns into 5,000 requests and your EC2 instances, or your single EC2 instance starts to not be able to handle that. What an auto-scaling group can do for you is scale that out. It can mean that your one instance becomes 5 instances. And then when that load, that request load, the number of people who are hitting your application, your servers, decreases, it will scale them in. So it will basically, it's responsible for kind of making this elasticity between the number of EC2 instances that you're using. And we'll talk about this and how it relates in a little bit, more in the demo than anything. So next up, what is ECS? Why you're here, why we're talking. ECS stands for Elastic Container Service. It is a container orchestration service. And that could be kind of an unknown topic to you. But what that means is that ECS is responsible for managing your containers, their life cycle, the scaling, scheduling, monitoring, and the underlying compute resources that your containers are running on. So it kind of provides a ton for you when you're running containerized applications. Some competing services that are similar to ECS. The big one is Kubernetes. It's an open source project from originally from Google, now kind of its own monstrous beast. Kubernetes is definitely the thing that if you're going to make the decision on which cloud or container orchestration service you're using and you're on AWS, you're going to think, hey, should I use ECS or should I use Kubernetes? And I think that, you know, Kubernetes is very complex. What I have down here at the bottom of this slide is that ECS is the best option for easily shipping container applications on AWS. I would say there's a certain number of services that once you reach a certain threshold, it doesn't make sense to run them on ECS anymore. Your application as a whole doesn't make sense to run on ECS anymore. And you should switch over to something like Kubernetes, because there's a lot of awesome development tooling and functionality within that service. But ECS definitely has a purpose, and it's easy to get started on AWS with containers with ECS. And I think that's a really important thing. And I mean, personally, I have probably across a number of my clients and across some of my personal projects, I probably have half a dozen, maybe a dozen applications running in production on ECS. And I would definitely say it's a production grade thing, and the easy part shouldn't be something you're scared of, right? It is ready to go. It does a great job of what it does, and it's worth checking out if you're on the AWS and you're looking to work with containers in any way. So yeah, let's jump into there's a quick slide. Prerequisites, they're pretty simple. You need an AWS account. You need a IAM account with adequate permissions. If you can just give yourself administrator permissions, I suggest to do so. You need the networking layer type of stuff. You need a VPC, a subnet, and a security group. And then you also need a Docker image, which you can use, which is your actual application that ECS will turn into a container for you. And you can have that hosted on a registry, and we'll talk about ECR, Elastic Container Registry, in a second. And then optionally, if you want to use EC2 as your launch type for your ECS application, you want an EC2 instance with the AWS ECS optimized machine image, the AMI. So pretty quick, the demo repo that I have shared kind of shows all of these things, what you need. It's using Terraform, but if you ever have any questions, feel free to just shoot me an email or something like that, and I can show you what you need if you have trouble. Before I jump into the slide, I'm going to take a quick drink. So, terminology and hierarchy. This is a big one. I'm going to be talking for a minute. All of these things are kind of what make up ECS as a whole. This is like our object model and what the kind of things that you need to understand to run an ECS application. So a cluster is the namespace. You can think about it as like a logical grouping of your resources. If you were to have dev, stage, and production environments, you would create an ECS cluster for each of those environments. And that would allow you to segregate those environments and keep them clean and kind of tidy so that you have a different cluster and a different set of resources for each environment. A task definition I mentioned briefly. We'll talk about it more in depth in the next slide. But these are one of the main building blocks of ECS. You can think about them as the blueprint of a logical part of your application. We'll show this more in the demo, but let's say you have a front-end service, a back-end service, and a database service. You would likely have a task definition for each of those, and each task definition would show you what container you want to run as part of your task definition. A task is an instance of a task definition. So you can think about task definition is the actual configuration that you're working with, and then a task is that is the real life thing that task definition actually embodies. So you'll have one task definition for your backend, but you may have 100 tasks that run all of the node processes that are your backend service. And then a service is a layer around a task. It is basically the primary means to spin up a long-running, stateless application. So yeah, in the example of a backend that you want to run, your service is associated with a task definition, and that service is responsible for spinning up the tasks. And if any of them die because they exited or they hit an error and they couldn't couldn't come back to life, then the service is responsible for spinning up a new task to replace the one that, that went kaput. So next we have ECS container instances and their corresponding container agent. You can see this well on the diagram we have here, but a container instance is really the EC2 container agent, or the container instance is really an EC2 instance that has the ECS container agent running on it, and the container agent speaks with your ECS cluster to do the ECS tasks like monitoring and scheduling your tasks on that instance. So to put in other words, your ECS container instance and container agent are the EC2 instances that provide compute to actually run your tasks. Pretty simple idea, might be a little bit hard to grasp, but we'll show that a little bit more in the demo. And I see a question here from Zia. Container agent is like Docker daemon. The container agent is actually a little bit more complicated than the Docker daemon because it's actually speaking with the AWS APIs to register that EC2 instance as a container instance and talk to the ECS cluster to determine what needs to be scheduled, what needs to be run, and reporting metrics and things like that. So it's a little bit more involved, but it is running the Docker daemon on that actual ECS container instance. I hope that provides some info for you. All right, so scheduled tasks. Scheduled tasks are a way to schedule executions of a task for a recurring time period or in the future. They use a triggering mechanism through CloudWatch events. We won't go into these too much, but I wanted to let you know that, like, if you have things like cron jobs, that's what they would map up to in the ECS world, is a scheduled task. And you can even use a cron-like expression to schedule a scheduled task. I mentioned this before, ECR is the Elastic Container Registry. If anybody has worked with Docker Hub or Harbor or Quay, they're all different registries. They're basically places to, when you build your Docker image locally, your image is ready to go, you need to push it somewhere so your application, your container orchestrator like ECS, can then pull that image and actually create a running container out of it. So ECR is the AWS registry for container images. And then finally, capacity providers, we'll talk a little bit about in an upcoming slide, but they are one of the ways to auto-scale your applications, and particularly the ECS container instances. The capacity providers are responsible for spinning up new container instances according to how many tasks you actually need to run at a certain time. We'll talk about that, and I'll show it during the demo, so I won't go too deep into that here. Excuse me, I'm going to grab another drink. This talking thing, hard. All right, so a task definition. On the left here, you can see this YAML. This is a task definition. A task definition, really, at the end of the day, comes down to a JSON or YAML document that you give to AWS that describes how you want your containers to run. It says, hey, here is the container image that I want to use. Here is the command that I want to execute against that container image. Here's the CPU and memory thresholds I want that container to keep. Here's the ports that I want it to expose to the world. Here's how I want it to ship logs. It determines the launch type, which we'll talk about in a second. It determines a lot of things. And this is why I say it's the building block of what ECS kind of does, is because it's the main piece of configuration that you're going to give to AWS to say how you want to run your different containerized applications. It has a lot of options. I can't go into all of them. You can see some of them here, and I enumerate some on the right. But we'll try and take a look at one of these before in our demo. So I'll go into this a little bit more. But just remember that when you're thinking about a task definition, think about it as the base building block. Think about it as how you want your containers to run. And now we come to launch types, which are an exciting topic because we have Fargate, which is basically serverless containers, which is a really cool idea. So when you deploy a task within Amazon ECS, you decide which launch type you want it to use, either EC2 or Fargate. Fargate means that you don't need an underlying EC2 instance. AWS has a fleet of EC2 instances behind the scenes that they manage themselves, and they place your task on those EC2 instances for you, basically making it so that you don't have to manage servers. If you are at all in DevOps, you know that managing servers can be a headache. It's painful sometimes, and basically the serverless model in the Docker world is a newer thing. And it's a beautiful thing. It's really nice. We'll talk more about this throughout, but it's really nice. So on the EC2 side, you obviously need EC2 instances to supply your compute, supply where you want to run those tasks. So you basically create a cluster of EC2 instances, that could be 1 or 1,000, and then you associate them with your ECS cluster, and then you're able to actually put tasks onto those EC2 instances. If those EC2 instances die, you need to spin up new ones, and all the fun stuff that comes with managing servers and managing EC2 instances. On the pricing side, AWS charges you for the benefits that it gives you with running a serverless Dockerized application. It's definitely more expensive. People, I believe the metrics that I always hear are that Fargate is around 30% more than EC2 is. And I think that that's a little misleading, because to make EC2 work for you well, it means that you need to really manage it well. Like, you need to be sure that you're using everything at the correct capacity and that you're not over provisioning your EC2 instances. With Fargate, you don't need to deal with that, but it's definitely more expensive on the Fargate side. There's a couple things in regards to data volumes, like what you can mount to your container, and networking types that Fargate doesn't have support for. Mainly EBS volumes, you can't mount those to Fargate. And on the networking side, there's a couple, bridge and host are two networking types that are common within the Docker world that you can't use within Fargate. The networking thing, really, I've never had a use case for bridge or host. Usually you can do like internal load balancing and stuff like that if you need to. On the data volume side, there's definitely a need for EBS volumes sometimes, but EFS is a recent addition where they allow you to mount EFS volumes, and that is kind of a good stopgap, right? Like it allows you to have persisted storage for your Fargate containers, and that's something. I think that most people can work with that as an option. From an operational perspective, EC2 is obviously higher to operate. It's going to take you more time. It requires more management, and it requires more involvement from a DevOps engineer. And then on the Fargate side, it's very low. You know, like if your task dies, Amazon's going to spin you up a new Fargate task. And it doesn't matter if your EC2 instance died or not. And it's fairly easy. On the debugging side, this is a big hit towards Fargate. And one of the things I'll address when we get to tips, the tips and tricks part, is that you know, EC2, you have the ability to SSH into your container. And you can actually use Docker commands to debug your existing containers. That's a really powerful thing. When you have like bad memory bugs, or you have a container that's just acting erratically and you don't know what's going on, it's really useful to have that. You don't have that on the Fargate side. There is no container for you to Docker exec into because you don't have access to the underlying server that's running that container. So it's just something to keep in mind. I have a recommendation for this at the end of the slideshow, and we'll talk about it a little bit then. And then finally, I just wanted to point out Fargate now has a spot option. So for people that are used to EC2 instances and the spot type, which is basically Amazon has unused compute capacity that they offer to you for much cheaper with the caveat that they might take that compute capacity away from you. They offer the same thing in the Fargate world where you can run on Fargate Spot, and it's much cheaper, up to 70% discounts in some cases. And that's awesome, but it only works for certain workloads because, I mean, it's just not acceptable to your users most of the time to have your containerized applications just suddenly get shut down. So Fargate Spot is awesome, but it depends on what workload you're using and how you're set up to support it. I'm just going to check we've got Nathan. Yeah, that's a good point, Nathan. I would just point folks to Nathan's comment about EC2 versus Fargate pricing. I think that that's valid. Moving on. We're going to talk about placement strategy and constraints. These settings, I want to make sure everybody understands, are only they only apply to EC2 instances. So, or the EC2 launch type. Basically, Fargate launch type spreads out your tasks across all of your availability zones that you have running, and EC2, you decide how you want to spread out your tasks. So for a placement strategy, you can think about this as how you want ECS to manage placing your tasks on your cluster. So there's 3 different types of placement strategies: bin, pack, spread, and random. And I'll kind of walk through an example here. Let's imagine you have 3 tasks that you want to place, and you have 3 EC2 instances that you could place them on. And let's say, well, I'll just go forward with, you have 3 tasks, you have 3 EC2 instances that you want to place them on, available to place them on. Bin pack, what that would do is it would place as many containers as it can on one instance, one EC2 instance, to then allow you to save costs by cutting out any unused EC2 instance. So if you had 3 containers and 3 tasks and 3 instances, bin pack would put, let's say, only 2 containers fit within memory and CPU bounds on one EC2 instance. It would fit 2 containers on the first instance, the 3rd container on the second instance, and then you could get rid of the 3rd instance and save yourself some money. Pretty useful for saving money, for sure. And then there is the spread type, which basically allows you to spread across a particular attribute, like availability zone is the one that I have in our example here, where you can spread, let's say you have 2 instances, both in US East 1A and the other in US East 1B, you can spread your 3 instances across those, or spread your 3 tasks across those 2 instances in different availability zones to ensure that, hey, if your 1B availability zone goes down, that you'll be able to continue running because you'll still have tasks running in your other availability zone. Very important for uptime and for probably your production environments. And yeah, these can be combined to kind of create complex strategies. And it's the same thing with placement constraints as well. Really, we'll go into this one, and then I'll say one thing about placement strategies and constraints that I hope can kind of bring it all together for everyone. Placement constraints are where you want your ECS to place your tasks on your cluster. They basically determine the node pool, the EC2 node pool, that you are going to be putting your tasks on. And really you do this through something called the ECS query language, which is a really simple DSL that you provide an expression and it basically queries all of your EC2 instances, and then that group of EC2 instances that match that query end up becoming your node pool that are going to place your tasks on. And that gives you a lot of power. What that's useful for is for ensuring that your tasks run on certain EC2 instances. So let's say your containers are, let's say you're Bitcoin mining. I'm not sure many people are doing that anymore because it's kind of hard to do. But let's say you're mining crypto and you want a GPU. What placement constraint would allow you to do is to set up your tasks to only run on your instances that have GPUs. So in the example that I have on the bottom here, we see that it's we have a cluster query language that basically specifies the instance types must be of G4, and G4 denotes the GPU optimized EC2 instances. So this basically allows you to create your node pool. So together, between these two services, between these two constraint, like these placement strategy and constraint systems, you can section up your EC2 instances to make sure that you're running your tasks in exactly the way that you want to either optimize cost or availability. And also, it allows you to make sure your tasks are running in the place that they logically need to be for their specific purpose, like GPU optimized workloads. We'll jump into this a little bit in the demo too. And finally, this is our last big slide, and I'll stop boring you with slides. We have auto scaling. And auto scaling comes in two parts. We have service auto scaling and capacity providers. Service auto scaling, this applies to both EC2 and Fargate. And basically, it's responsible for scaling the number of tasks that you want to run. So the number of containers that you want to run for your application, this is responsible for that. So, and it allows you to do so on CPU, memory, and incoming requests. And basically, similar example to previously when I was talking about auto scaling groups, is if you have 1,000 requests coming in, you have one task that's handling that well, suddenly you have 3,000 requests coming in and you need more tasks to handle that. That's what service auto scaling does, is it allows you to basically set up those, when you want to increase your tasks and when you want to decrease them according to how much load your application is getting. And then there's capacity providers, and again, we'll talk about these more in the demo. They're somewhat complex because you can make them as complex as you want, kind of. These are just for EC2 because they're responsible for scaling the number of EC2 instances that are running your tasks, right? So you have the number of tasks being scaled by your service auto scaling, but the tasks, if you're running on an EC2 launch type, they need to run somewhere, right? They need backing EC2 instances to actually run those tasks. And sometimes you don't want to be running 100 EC2 instances, so you have a small amount, and then if your tasks increase, you need to increase your EC2 instances as well. So that's what capacity providers do for you. They're basically associated with a auto scaling group, the thing I described at the beginning of the talk, to allow your ECS cluster to increase or decrease the demand of EC2 instances that your cluster needs to properly run the amount of tasks that it's working with. And these can be combined again to create complex workflows. And one nitpicky thing if you get big into ECS, you'll hear a lot from people that they do a poor job of scaling in and decreasing capacity, and that's because they will not, if there's like one task running on one EC2 instance, they won't move that task from that EC2 instance to another EC2 instance that could work. They will just keep that task running there and leave that EC2 instance running, even though really you don't need that EC2 instance running because that task could fit somewhere else. It's frustrating. A lot of people have workarounds to deal with that. Yeah. All right. We've come to the demo portion of our talk. And I am going to show you folks our application, and then we'll go into the ECS console. We'll do some scaling. I'll show you a couple of the things that we were just talking about, and should be fun. So our application, we've got our handy dandy to-do app. This is at ECS101.masterpoint.io, but we've got this to-do app. We can add to-dos. This application uses a front end, a back end, and a MongoDB database. So we can add new to-dos here, like get milk, grab present for girlfriend, pick up car, you know, all the fun things that you add to a to-do list. There isn't a way to actually cross off these to-do items. That is, I copied this application from a project called Awesome Compose, and I linked to that in the repo. But you know, they didn't have the ability to actually mark a to-do item as done, which is fine. We're going to deal with that at the end of the talk. And I'll show you a cool thing that you should be able to do with your containers and with your applications in a little bit. So let's first go and look at a Docker Compose file for this project. And we'll be able to like talk through what this project is actually doing. So like I said, there's a front end container. It runs a small file server, and it exposes a port to the outside world. And then we have our backend container, which is a Node.js Express app that simply, all it does is it returns all of the to-dos in the database, and it also allows you to add new to-dos. So I didn't show this, but we can actually go to our React app here, and we can refresh, and it's going to show the same list of to-dos because they're persisted to a database. Speaking of that database, it is a MongoDB database. So this is a Docker Compose setup. This is what this application looks like if you were to run it locally. And what I would like to show you is our ECS console, where you can see we have an ECS cluster, and we can see basically all of these services that we're running here. We're running the same in our ECS console. So here we are in Oregon, US West 2, and we have our MP ECS 101 application. So if we click into this, we will see we have 3 services, the same names: front end, database, and back end. And with that, we have 3 tasks. We have a front-end task running on Fargate. We have a back-end task running on EC2. And we have another database task running on EC2. And what I'd like to show you is, one, we have 2 backing ECS instances. If we go over, we have a back-end EC2. This is in our EC2 console. We can see that we're on instances. We have our backend EC2 instance, and we have our DB EC2 instance. If we go over to our cluster, we can see that these correspond to 2 instances on our cluster. So we have 2 container instances, ECS container instances, that are each associated with an underlying EC2 instance. So this is kind of a few of the things that we were talking about, right? Like we have these two instances, and one thing I want to mention to you is why are, if we have like CPU and memory available, why is our two instances running, or our two tasks running on two different instances? So let's go and look at our database service, and I'll show you an example of a placement constraint, because that's what's causing that. Basically, we have a placement constraint on our database instance, or our database service, because placement constraints and placement strategies can both be specified at the task definition level, and they can also be specified at the service level. But we have a very simple placement constraint here, which basically says put all of the tasks for this service onto T2 instances. So we're running one task, and that one task is, my console is slowing down, folks. That one task, if we click into this, is running on our container instance here, which is associated with this EC2 instance, I087. So if we go over to our instances, we can see that our DB EC2 instance is our I087, and it is a T2 small. So that placement constraint that we saw that was saying for that service to only place tasks on an EC2 instance with T2 small is what allowed this our DB task over here, what allowed that to run on that particular EC2 instance. And that's why we have our two tasks, our backend task and our database task, running on separate EC2 instances. So that's just a quick example of a placement constraint. And now we'll kind of get into something more interesting. So I have 3 services here, and I've got a backend service, and really I want that backend service. I'm suddenly getting a bunch of load. Currently my backend service is only running one task, and I want to increase the number of tasks, right? So what I'm going to do is I'm going to fire off a command line tool to scale up my ECS service. And what this is using is it's called this tool ECS is really called is a tool called ECS deploy. And I specified my cluster name and my service here, and the number 6, which corresponds to how many tasks I want to run, and it goes to AWS and tells AWS, hey, run 6 of those tasks for me. So we're going to see, hey, now I have 6 desired tasks, and if we go over to our tasks, what's going to happen is those are going to start to spin up new tasks in the provisioning state. So you can see that here. We have 4 new ones. There's more coming. Or we have 4 new ones and we have 2 running. So one of them, previously we were just running one backend task. And now we have 2 backend tasks running, because one of them was able to fit on the existing backend EC2 task. But we have 4 in the provisioning state because they don't have an EC2 instance to run on. They can't run on the the database instance, and they're kind of stuck in limbo right now. Luckily, we have a capacity provider. So if we go, that was weird. If we go over here, I'll show you that we have our backend capacity provider, and this is associated with our backend service, and it's also associated with a auto-scaling group. So if we go into our EC2 instance console, we can see we have an auto-scaling group, and it's associated with our backend capacity provider, and currently it has one instance that it's running. It has a max of 3, and its desired capacity is 1. If we refresh this, we're likely going to see this number go up. Because there is tasks that are stuck in that provisioning state, what ECS does is it basically tells that capacity provider, hey, I need more capacity. I need more EC2 instances to run. And what that ends up doing is it sends a signal to this auto-scaling group to spin up more tasks, or spin up more EC2 instances. And now this is not liking me right now. It's taking its time, which I'm surprised by. In previous run-throughs of this, I haven't had problems. But soon, what will happen is that we'll get a new EC2 instance that will allow us to run 2 of those tasks that are in the provisioning state, and then eventually we'll even get a 3rd EC2 instance that will allow us to run the final 2. And we'll keep an eye on that. What I'll do is I'll move forward to the Fargate part of the demo, and we'll come back, and I know that there will eventually be a EC2 instance that ends up getting spun up so that these provisioning tasks have somewhere to actually run. So let's talk about Fargate. We have our single front-end task running on Fargate. It is the Fargate, our service is using Fargate as its capacity provider. And in the beginning of the talk, I lied to you folks. I lied to you quickly in the middle of the talk too. There are capacity providers for Fargate, but they're implicit. They come with creating a cluster, because there is no EC2 instances to manage for Fargate, but AWS has capacity providers so you can do things like this, which is what this is saying here is, hey, we have a Fargate and a Fargate spot capacity provider combination, and we have a weight of 10 for our Fargate capacity provider and a weight of 90 for our spot provider, and we have a base of 1 for our Fargate. This base of 1 corresponds to the desired count of 1, and what this means overall, to give you a clear picture, is that for every 10 front-end tasks that get deployed, 9 of them will be Fargate spot tasks. They'll be running on very cheap hardware that AWS might pull away and shut down my tasks. The other 1 will be running on Fargate. So if I spun up 20 new tasks, we would get 2 Fargate tasks and 18 Fargate spot tasks. So let's spin up, similar to what we did with our backend, let's spin up 3 Fargate tasks, and I'll be able to show you what I'm talking about. So this will happen a lot faster because ECS, oh, I spelled that wrong. Sorry, folks. Saying Fargate too much. So this will happen a lot faster because with Fargate tasks, we don't actually need to wait for any EC2 instances to be able to run, and it'll just spin them up quickly. So right now, our Fargate service has a desired task of 3, and if we go over to our tasks, we'll see those new desired tasks get spun up. And I wish I could expand this a little bit, but here, well, now we have 4 backend tasks. So there was, like we were looking for that EC2 instance to come in before. If we go over to our EC2 console, we can see that we're now running 2 backend tasks, which basically allows us to spin up 4 of our backend service tasks, and then we're moving forward. We're slowly scaling up our backend service. On the front end side, we've got 3 tasks, and they're all now properly running. And what we've got is this one, and this one, and this one. And if we go in and look at these, we'll basically see that some of them are Fargate, or one of them is going to be Fargate. It's using the Fargate capacity provider, and that means I'm paying full price for it. And then these other two are going to be Fargate Spot, and that means I'm paying a lot less for them. They have more chance to be pulled away from me, but I'm paying a lot less. So these two here, because I had that capacity provider set up where I was using two capacity providers on one service, and I had a weight of 10 for Fargate, and I had a weight of 90 for Fargate Spot, I now have one Fargate task and two Fargate Spot containers. So that's an example of using Fargate, and also an example of the Fargate Spot capacity provider type of example. All right, so now we've gone through placement constraints. We went through a capacity provider on the EC2 side, and we went through a capacity provider and Fargate on the Fargate side. So you can see here, we still have those two tasks provisioning, and I'm sure that at this point, maybe our third EC2 instance is getting spun up. Not yet. It's going slow today. But basically, that shows a few of the things that I've been talking about during our slideshow. So one thing I want to show you that can be really beneficial for you is, like I said before, there is no way to cross off these tasks, right? We don't have a way to actually make sure that these are no longer around. You know, I don't have any way to say, hey, I got the milk. And if I was a product person and I didn't have a way to do that, I would need some, you know, like, this is useless to me. I can't just keep adding things. So one way to do that is, what if we had a background job that did that? Kind of a odd, esoteric way to accomplish this task of just crossing off items, but you know, background jobs and things like migrating your database, seeding your database, you know, one-off reporting jobs, things like that are really common to have to run within the DevOps space. So one thing that I'm going to show you folks is in our ECS demo application, we have this ECS run.yaml file. And if I bring that up, it basically is just a simple YAML file that provides a couple pieces of information about our cluster and about a task that we want to run. So AWS provides a run task API that basically allows you to invoke a task whenever you would like. And it's outside of a service, so it allows you to do things like run one-off jobs. And you can override your existing Docker command to do different things than the original Docker container was expected to do. So I have built a tool, and you can do this simply through writing a bash script against the AWS command line application. But I've created a tool that invokes, called ECS run, that invokes the run task API, and it will push up a new task to our cluster to invoke this overridden command. And if we go into our ECS cluster, we'll see this running. So if I refresh the list of tasks, we're going to see a new task in here. It is a backend task. It's in pending. It's not associated with a service, you'll see. It's on its own. It doesn't have a service that it's associated with. But it's a Fargate task. And if we click into this, we'll be able to see that, oh, it already exited. So if we go into our logs, we can see why. And, oh, it connected to our MongoDB application, and then it successfully deleted all the to-dos. So if I refresh our page, now there's no more to-dos. So it was a pretty simple way to show you, hey, here's a way that you can run one-off jobs using ECS and kind of accomplish your administrative tasks. That's something I would call it. And with that, I will end our demo of the application, and we'll jump into the last couple slides that I'm going to show. So here's one slide I'm sure lots of people are interested in. For those of you that know ECS, this might be interesting to you. I hope some of these tips are good and they save you some time or save you some headaches. But yeah, I'll jump into them in a second. So generally, I was talking about Fargate versus EC2 before, and I think this is one of the most important things that I would suggest. Unless cost is ultra critical, I would use Fargate whenever possible. I think it's a great service. It saves so much DevOps and like operational overhead that it's probably worth the extra costs. And it's just a good service. It just gets things done for you quickly without as much headaches as using EC2. With that, EC2 as a launch type provides a really solid option for tricky debugging scenarios. If you need to know what's going on with your containerized applications, running them on EC2 will allow you to get that deep insight and kind of play with the command line to see what's going on. But for the most part, I would say run on Fargate and use EC2 as a backup. The update account settings for long ARN formats, for long ARNs. AWS has come out with a new format for their ARNs, their resource names. And for some reason, they're really dragging their feet on updating ECS to use these new formats. They've mentioned in the past that they were going to cut everybody over months ago, and then they didn't do it. So these are commands. You can come to this slide deck. The link is in the YouTube chat, and you can check out these commands. And really, I would just copy them and always run them against a new AWS account. They're really simple, and they're just going to save you some headaches where there's some incompatibilities between the long ARN formats and the old formats. So yeah, I just suggest running these commands. As we were talking before, the Docker command plus run task API, I really suggest using that for your administrative benefit. I think that it's really useful to do things like database migrations, seeding your database, or one-off reporting jobs. I use that a lot. I wrote my own tool around it, and I'll have a link to that in a bit. But I think it's a really important and useful thing when working with ECS to make sure that you're aware of it, to make sure that you're using it to your benefit. And then kind of a controversial thing, I think that environment variables and secrets, you can supply these things within task definitions, and I would suggest against doing so. I think it's really kind of cumbersome. It makes changing your environment configuration painful. It means you need to do a deployment every time you want to change an environment variable. Sometimes environment variables are really volatile. You want to change them often. And yeah, I think doing that through task definitions is not the right move. One suggestion, so I say find another way. Keep them blank in there. And the suggestion I have for you is using AWS Parameter Store and a tool by segment called Chamber. It basically allows you to easily inject configuration into your Docker applications right when they're starting, so that if you have changes to your configuration, it just requires restarting the tasks in your app, which is super simple, and you don't need to do a deployment. Pretty quick and easy. I'll have a link to the segment chamber tool and AWS parameter store pattern in the resources. They actually worked with AWS and have a blog post with AWS. All right, and my last kind of tip is, and this is just a general Docker DevOps tip, is don't use the latest tag. And I have a blog post that goes into this in depth, but I've been bitten by it. I know friends and clients who have been bitten by it, but the latest tag is an anti-pattern. And it's probably okay in your dev environment. It might be okay in your stage environment, but definitely don't use it in production. And the reason why is just because it can lead to not knowing what container you're actually running. And it can lead to sometimes, in my case, I had it happen where it ended up deploying a application for a client when they didn't even want to get that thing deployed yet. It wasn't ready to be deployed. So what I say is, my suggestion is each time you build a new image for your production environment at the minimum is update the associated task definition and do a deployment with that. Updating an associated task definition is easy with a tool like ECS Deploy, which is in the next slide. And I suggest that just because I think that it's going to save you headaches in the long run. And then the final thing for tips and tricks, it's not really either, but know that ECS isn't perfect. There are rough edges. AWS is trying to keep up with Kubernetes and similar offerings, and you know, their consoles are, everybody gives them a hard time for that. They don't do a good job with shipping a polished product sometimes, but it's solid and it's dependable and scalable. And I think those are really important parts to go into it knowing, is that, hey, it isn't perfect, but I'm going to be able to ship my app and not have to worry about it going down all the time. And I think that's a big thing to be said about AWS overall. Okay, let's talk about tools. Some of them I've already mentioned. ECS Deploy is what I used, was this tool that I used to fire off our scaling action. This ECS project is, it allows you to do a few different things, and it's super useful. I think it's well established within the community. You're able to do a lot of complex actions with it, and it's a good tool. I would check out what it can do for you if you're using ECS, and definitely see if you can work it in somewhere. My own open source project that I showed you folks, ECS Run, is up on GitHub. It allows you to easily use a config file for executing one-off tasks. Super simple. Check it out if you're so inclined. And then there's the ECS CLI. Excuse me. It is Amazon's own CLI app, and I've never personally used it. For some reason, I'm not interested in using it. I have my own tool set already for deploying ECS applications using infrastructure as code tools like Terraform, and that's kind of my realm. The ECS CLI, though, is something interesting. I think it's worth investigating if you're new to ECS, because it does provide some really useful things for you, like easily creating ECS clusters and whatnot from Docker Compose files. But check it out. I know that they just came out with a version 2 that they're excited about, and it might be something that you could use that would be beneficial to you. And then finally, there is an awesome list for ECS. It's a curated list of guides, tools, and resources within ECS that are awesome. I mean, the guy Nathan Peck, I think he's a developer evangelist with AWS, and the list is really well done, and I think there's a lot of good stuff in terms of guides and tools in there that you should check out. And where to learn more, folks? We're coming down on the wire. Bunch of things that are pretty no-brainer, right? Like ECS docs, you're going to learn a ton there. If you're new to ECS, you're going to be able to get the deep dive into the internals and understand all the different options for your task definition and whatnot. You can check out my demo project. That gives you a full Terraform workflow for deploying an ECS application and provides some task definitions, all that fun stuff. There is the AWS Container Roadmap. This is both for AWS's Kubernetes offering, EKS, as well as ECS. And it's a really good place to go for issues that you're not sure if you're like running into something that's odd. Maybe it's already reported in the container roadmap. Maybe it's already on AWS's mind. Or finding out new functionality that they're going to be coming out with is a big one. Yeah, and then there's the blog post on ECS Fargate Spot. That was a recent addition, I believe, in 2009. So definitely new and kind of exciting. We can get cheaper Fargate running. We can get Fargate running for cheaper, so check that out. I saw that Austin posted the Segment IO Chamber application in the chat. So if you want to go there, you can check it out on GitHub. But also the link that I have in our slide deck here is the AWS blog post. Definitely goes into depth on how that can be used to manage configuration with ECS and with Docker containers in general. An important one is the Docker latest pattern being an anti-pattern. I suggest reading that if you use Docker and avoiding latest. Again, I'm saying it, but avoid using latest in your production environments. And then finally, I really like the folks at Cloudonaut. They're two German brothers from Berlin. They have a bunch of posts on ECS, and two of a couple good ones are EC2 versus Fargate and EC2 versus Kubernetes. But in general, head over to cloudonaut.io because they have a bunch of good resources for shipping containers on AWS and kind of keeping all of that running. And that's it, folks. I am done with my slides. We're done with the demo. I'm happy to take any questions. If anybody has any, please shoot them over into the chat, and I'll give you a couple minutes to do that. But yeah, it was a pleasure. I appreciate taking the time and watching. And yeah, if anybody has any questions in general, feel free to reach out to me on Twitter at GowieM. Yeah, through the meetup. Yeah, always happy to chat with folks and happy to answer any questions or help out. It's been a pleasure. I am not seeing any questions come through, though I know that there is a 90-second delay, so I should probably give it a little bit of time. Okay, Michael Suttles asks, thoughts on Lambda versus Fargate? It's a good question. They're two different beasts. I think Lambda, I'm not a big serverless person, so I haven't used the serverless framework. I'm much more of a Docker person. But Lambda, I think you can build applications completely on Lambda, and you get all the benefits of serverless, right? Like Lambda was one of the first serverless offerings that was out there, if not the first. And I think that both are really nice, right? Like I used to, when I first got into DevOps, when I first got, I became a manager and I started managing applications, and I was the only person that really had the time to deal with our DevOps stuff. I managed a ton of EC2 instances, and I was getting woken up all the time in the middle of the night because Ops Genie was pinging me, calling my cell phone, telling me, hey, this server went down. It's painful. The serverless paradigm, this like new cloud enablement of using serverless is fantastic. So in general, I would say if you're shipping microservices and they're on Docker, I mean, it depends on if you want to use Docker or not. I think that's the question. Fargate, you're using Docker. Lambda, you're not, but you're still in this rich ecosystem of serverless functions, and I think that's awesome. I think it's up to each individual organization. Unfortunately, I don't have a better answer than that, I think. So sorry to give you a kind of wishy-washy answer. But a good question. It is just up to your own organizational perspective. Cool. Thank you, folks. I appreciate it. We'll go with that. Oh, okay. Hold on. We got a question. Michael Duncan. Thank you, Duncan. Thank you, Michael. What are your thoughts on a DB on an EC2 versus one of Amazon DB services like Aurora? Definitely always use Amazon DB services. RDS is fantastic. I was running a DB instance and running a database through ECS. I would never do that in a real life scenario. I should have made that clear. AWS has put tons and tons of effort into their RDS service to make it easy to run a database and make it scalable and available, and they charge you a little bit more for that than just regularly running on EC2, and they give you a little bit less permissions, but it's their expertise in that world, I think, is really one of the things that I would never question. I mean, running on RDS is definitely the better option than running your own self-hosted database. There are reasons to run a self-hosted database, like cost for your dev or stage environments, or if you really are doing heavy database stuff with specific databases, then there's reasons to run in different environments. But if you're running a Postgres database, a MySQL database, or something like Aurora, which is really even takes it up a notch above even what RDS provides, I would totally just use RDS. I think that it's a great way to run a transactional database and well worth the extra money that they charge you for it. And yeah, Nathan mentioned OpenFaaS. Awesome stuff. The function as a service world is super cool. I just am not a part of it. I definitely am more of a, I deal with servers and EC2 instances and DevOps and not really on the serverless side. The nice thing about Fargate and ECS is that I get the benefits of serverless within that Docker and within that like more common DevOps world without the hassles of dealing with EC2 instances. Cool. Awesome questions, folks. I'm going to leave it at that. I appreciate it again, and thanks for taking the time. Austin, we didn't really talk about how I would wrap up, but I am just going to end the talk, and I appreciate it, folks. Have a good one. Thanks.